Okay, hey guys. So I go through some hints and reminders uh, for day 3 of the Percent Copper Lab, and so you may have forgotten kind of how to do a few of the calculations. I hope you still remember, but we forget over time. So looking at this first question here, so it says we've got a total of so many grams of copper creating a 500 milliliter solution. That was what we were supposed to do. You guys had about, I think it was 7 point something grams of copper, and we diluted in a volumetric flask to 500 milliliters. So let's just say it was, let's see, let's get pen going. 7 point whatever, I don't know, some amount of grams creating 500 milliliters of solution. To find molarity, I hope you remember that the molarity is the number of moles in the liters of the solution. And so you could find the number of moles from your grams of copper using your periodic table, of course, to find the molar mass. Take your moles and divide by the liters of solution, which in this case is half a liter, 500 milliliters. Or you could solve the problem using what you know, which is basically the density of the solution. You know that you have 7 point something grams in 500 milliliters of solution. We're trying to teach you guys some quicker, easier ways to solve these problems to save yourself some time. Actually, we don't know what that is. But 7 point something grams in 500 milliliters or 0.500 liters. That you know. So you can change grams to moles by using the molar mass of the copper. That would be the amounts in moles. And then you would have moles of copper for liters of solution. The grams of copper here cancel and grams of copper here would cancel. And you'll end up with the concentration of the solution. This would be your stock solution. This would be the amount of copper, or the concentration rather, of the copper that you had in the volumetric flask. Then what you're going to have to do is you're going to take dilutions of that. So you're going to take your stock solution and dilute it to 4 different concentrations. The first one being 0.20 molar, another one being 0.10 molar, another being 0.050 molar, and the last one I believe was 0.025 molar. So you'll need to show how to do that. Well, how you do a dilution is using your dilution formula, M1V1 equals M2V2. So solving that way, your M1, it doesn't matter which one you do as long as you keep the volumes the same, but I'll use my stock solution as M1V1. So my M1 is something that I'm going to calculate up here, right? So my M1 I solved for, and I'm going to move this down here. So my volume 1, I don't know. I don't know how much of that solution that I need. And then what do I want to end up with? I want to end up with 0.20 molar. And what I want, I think in the lab, I may be mistaken, but I think it's 50 milliliters of each solution. And so you would go make 50 milliliters. You don't have to have that in liters since you have volume on both sides of the equation. You could, of course, use 0.0500 liters if you wanted to, but 50 milliliters for the dilution. The answer you'll get is how much of that stock solution you need to add and then dilute to 50 to find. So you guys need to be able to explain that for all those different dilutions for the last one. Now, down there on the bottom, it says, make sure you show me your calculations. Calculations for each one of those solutions. I want to see a 0.2 molar calculation, a 0.1, a 0.05, and a 0.025. And then you need to write down how you're going to do that. What glassware are you going to use? You're going to magically have a 50 milliliter volumetric. That's okay. You're going to use graduated cylinder. You're going to use a beaker. You tell me how you're going to put them together. But you need to show us that in the pre-lab for part 3 or day 3 anyway.